Hi, I'm Eileen.
Hi, I'm Jeevi, and today we are excited to present our Java console based app called the Personal Carbon Footprint Tracker.
This app was designed to help users become more aware of their carbon footprint by tracking their daily activities and giving suggestions to reduce emissions. The Personal Carbon Footprint Tracker is a Java-based console application designed to help users track their daily carbon emission through their activities. This application encourages climate-conscious decision-making by allowing users to log their activities, such as transportation, electricity usage, and dietary choice. The application also features an emissions calculator that calculates the carbon impact of these activities using real-world data.
So, right now, I'm going to talk about the problem statement and the objectives of this whole entire Java app. So, one of the biggest contribution to the climate change is the lack of awareness among people. So, many people don't know how their actions every day, like driving or using electricity, add to carbon emissions.
Our aim was to build a beginner-level Java app that helps solve this by allowing users to log their action, see how much CO2 they produce, and get eco-friendly suggestions.
So this project directly supports the SDG 13, which is the climate action movement, which especially targets 13.3, which focuses on awareness and the education part. So as you can see here, this is the login class, and this one users can use it for their register and their login. And I created this using a buffer reader and buffer writer to handle the text files. So how this thing works is that um, the user has to register and create like an account before actually logging in, and this is basically for the user's authentication. And basically how it works is that if right now the user and password will actually go to the text file, and it will come back. Basically it'll go on a loop where it will search for the similar name. Whenever they're logging in, they registered with 123, so it will go into the text files and see username 123, and then it'll let you to log in. So that's how this works. So uh how it now I would show you the input and the output of it. Since now we already register, and we can also log in now. There we go. So now next we have the log activity. The log activity is to log in the user's activity of the day. For example, they could say that they went for a bicycle ride. They took the bicycle, or they could probably they drove a car for 10 kilometers. So it will log in their activity of the day. So where does this go? It goes to the text file that I created as well. It's similar as the login file, as the login text file. It goes back and forth, and I used the file writer in a append mode so that the new entry goes to the end of the file, and after saving it, it'll show the message to confirm the activity was logged in. So right now I would show you how it works, the input and the output of it. So as you can see, you have one, and then since I chose one, the user chose one, and you'll have three modes, and the three modes you can choose which one you want, and then you can log in your activity. And once you log in your activity, it will ask you questions that are regarding that each things that you chose, and you can enter your date, and there we go. the activity is logged. It will say the activity is logged.
Okay, now is for view activities. For view activities, this method is to display all the activities that belongs to the specific user. It will read the activity txt file line by line and check if each line match the specific username, and if it does, it will show the activity details with ID numbers. The ID numbers are added because it will be useful for updating and deleting the activity. So now I will run for the view activity. Okay, if the user choose to for view activity, then the user can see the activity that he had logged before.
So right now, I am going to talk about the update activity. So the update activity, what it does, it's that from the list of a user, from the list of whatever activities that they logged in, they could update it. Probably they thought that they walked for 5 kilometers. But then when they checked their real time, it was probably 10 kilometers. So they can update it from there. So what does this do is that uh from the activity ID that we got from the view activities just now, uh it reads line by line, and it will find the matching line based on the username and the ID, and it will replace that line with the new details, and then it writes back to the file, and the message will be shown saying that the update is complete. So that's how the user would actually use it, and that's how the system will go. So right now I would show you the input and the output of it. So it will say like that.
Okay, now is for delete activity method. It can delete a specific activity using the activity ID. It will read the all activities into an array list, and it skips the one to be deleted. After skipping the one to be deleted, it will write back all the other line to the activities txt file. Lastly, a message will be shown after it deletes. Now I will show the input and output. Okay, just log in. Okay, then user can choose the for delete activity and insert the activity ID. Then it will show activity deleted.
So next is the tips generator. The tips generator is a constructor that set up an array list, and it adds the environmental tips whenever the user have any menu. Once they log in, every time they see the menu, they would have the tips on top. It's just for a reminder saying that, okay, so today you should not do this, or use public transport to reduce your carbon footprint. It's just like a reminder, and it's a fun little thing that to just focuses it just mainly focuses on reducing carbon footprints. Is to give the users just a little bit of a reminder each time when they're using the app.
Okay, now is the suggestion engine module. Suggestion engine module can prompt user to enter their daily activities like car, meat, electricity, and more. Then it can given an eco-friendly suggestion for reducing their carbon footprint based on their chosen activity type. It aligns with SDG 13 by encouraging users to have a greener habit through their personalization advice. The technologies that we have used in this are array, string handling like equals, ignore, case, for loop, while loop, and if else to match activity types with suggestion. The main method is using like suggestion. And the first prompt is to let user to input the number of activities they would like to enter. And then at here, we will check about the input validation, like ensure the user enter a number, not alphabet. At here, we add a array list to store the activity names. At here, we write a for loop to collect each activity and give the suggestion. The suggestion like if the user input the car, we will give some suggestion like try walking or public transportation such as LRT and train. Now I will show the input and output. Choose the number 6 for suggestion engine. Enter one or more. Enter the activity name that have shown at here. Like now I want electricity. Then it will show a suggestion for the user. Turn off the electricity when unused.
So right now we are going to do the demo. So as for now, this is the demo that we're going to do for the whole entire application. Right now, as you can see, is the login and register site. So first, we're going to register, add our username first, and then the password. And this would go to the text file. And now, from the text file, it will try to retrieve back the information when we are logging in. So as you can see, we can register. After register, we can log in, and you can see the main menu. Every single time when the main menu pops up, there will be a climate tip of the day. It will change throughout the whole entire time when it's generating, and this is basically to motivate the users to not have their carbon footprint, to not increase their carbon footprint, or it's a tip for them to motivate them to make it lesser. So we have 7 options in the main menu. First is log activity, second is view, third is update, fourth is delete, fifth is emission calculator, sixth is suggestion engine, and the final one is to exit the whole entire loop. So we are going to start with number 1 first, log activity. So from log activity, we can choose a category: transportation, electricity consumption, and food consumption. Okay, so right now we can choose either we drove a car, rode a motorcycle, took the public transport, or walked a cycle. So we have a choice to option A to D. We can choose A for now. So we can put in the distance that we went, the date. We go by year, month, and date. And then the activity will be logged. So we choose the second option. Okay, this is to view. So as you can see, we can have the ID. So this is very important. The ID is very important for the next few steps. And then type, and then the quantity, which is how far you went, and the date. Third is update activity. So if you want to update, you feel like, oh no, I actually went more than 23 kilometers. So you can do it here again. New type. So what did you do? Drove a car. Okay, drove a car. New quantity. Okay, how many kilometers did you go? And then new date. Oh my god, wrong date. And then you can update the date. So it'll say activity updated. To recheck, you can maybe go back to the view activities again. And then number 3 is, as you can see, it has updated. Okay, so right now we are going to delete the one of the IDs. Okay, so now we choose number 4. And so now, for example, the activity ID, which is really important. So we put number 0 and it will say that activity is deleted. So now let's view. So as for now, if you really see, it's meat consumption. Just now it was the car, drove a car. So now it's meat consumption instead. So now let's go for, so that's how it works. If now you delete one from ID 0, the first one, which with the one with ID number 1, it'll go up and it becomes 0. So next we have is number 5, emission calculator. So for the emission calculator, it'll once the user puts 5, and it'll first thing that comes out is how many activities to enter. Maximum you can only enter 100. So we put 2. All right. So activity 1, enter the activity name. So car. So the amount, we can choose whatever amount we want to, for example, 2 units to. Next is enter the date. So now we enter the date, and then you will have the second activity to add as well. So you choose another activity name, pick your amount, enter your date, the same exact thing, and then you would have a small report here. As you can see, car 2025, July, electricity, total emissions, how much is it? And next, we could go for suggestion engine. So suggestion engine, how does it work? So you just put that, and then it'll ask how many activities do you want to input. So you could put as many as you want. So 2, for example, we put, then we can enter the activity name. According to the activity name, it will give you a suggestion. So try walking or using public transportation, such as LRT, train, like that. So for the second one, motorcycle, you can choose. It will say try to ride a bicycle instead. So it's to motivate the users to reduce the carbon footprint. For the number 0, as you can see, once we enter 0, it will say goodbye. And it will give you a motivational thing saying that keep reducing your carbon footprint. And it just ends the loop right there.
Now I will present the emission calculator module. This module allows users to record their daily activities like driving a car or using electricity, and it will calculate the amount of carbon dioxide produced and then generate an emissions report for the user. This module uses basic Java features such as arrays, for loops, if-else statement, try-catch for error handling, and scanner for input. It only used text-based data. We didn't use any database. First, it will ask the user how many activities they want to enter and make sure its answer is between 1 to 100. Then they need to choose the activity they wanted, such as car, motorcycle, electricity, and meat. After that, after they enter the amount, like for car, is 0.297 kg CO2 per unit. When the user enters an amount, the program multiplies it by the factor to get the total emission. It also checks for errors like wrong activity name, wrong amount format, or wrong date format.
So now, since the video is ending, we would like to conclude that this application was developed using only core concepts of Java that we learned this semester, including file handling, selection structures, loops, and arrays.
It helps users become more conscious of their carbon impact and supports global climate action in a meaningful way. Thank you for watching our presentation.
Thank you. Bye bye.
Bye bye.